So good morning, everyone. My name is Gulliver from GA Fleet. So here we have our fire pump control panel. Here we have our fire pump, our motor, our system. Here we have our jockey pump over there. And here we have our jockey pump controller. So a couple things to keep in mind before we operate this equipment. We do have 400 plus voltages actually coming into this fire pump control panel, which could be seen over here across their LED screen. So this would be your electrical hazard that you would have. For no reason, you would want to actually open up this control panel and go into it because of that electrical hazard. So any mechanical and chemical hazards that we do have, when this fire pump does operate, we are creating turbulence with water. And we're putting mechanical stress on the piping itself. So when we do operate this fire pump, we don't want to have more than 2 people in the fire pump room while this pump is operating for safety purposes and for everyone to evacuate if anything did go wrong. We're not in the current construction site, so hard hats aren't required. We don't have anyone drilling over our heads. When you operate this fire pump, we don't want to have any jewelry, any tags hanging off of us, any pens or anything caught on your shirts that could fall into the fire pump. Any females operating this fire pump, you want to have your hair tied back so it doesn't get caught into the impeller when the fire pump actually operates. So our fire pump controller is actually a FTA 1930 fire control soft start controller. So when I say soft start, that means this fire pump is going to slowly start up and it's going to slowly stop down. The reason for that is going to reduce the mechanical stress that's actually put onto the fire pump system when your fire pump actually first starts up. So here we have our circuit disconnect switch. Killing this switch is going to kill power going into our breaker that will feed the motor with energy and make the motor run. So here we have our start button. You push this button one time and it's going to slowly start the fire pump up and bring it up to full speed. Here's the stop button. We push this button one time and it's going to slowly stop the pump down. Our emergency switch, our emergency stop button here, you push this button and it's going to bypass that soft start and soft stop, so it's going to quickly stop this fire pump. This touch button here, you push this button here and it's going to simulate loss of pressure. We're going to drop pressure there at the drain and the fire pump is going to kick on. So this is basically a simulation of pressure loss in the system. Here we have our emergency run handle. By pushing this handle, it's going to, again, bypass that soft start and it's going to apply full current into this into our breaker here and give our pump, our contactor, and give our pump full power. So in this building, we have emergency power here. So here's our emergency power transfer switch. Once again, here's our disconnect. We turn this disconnect off, it's going to kill power going into our circuit breaker, which in turn go to the contactor and into the motor. We have 2 switches here. Our first switch here is our transfer switch. So right now it's always going to be in the auto position. Our circuit breaker to the generator is always going to be in the on and auto position. So here, if we had a loss of power, the controller is going to switch power automatically. If we hold this button to about 10 seconds on the test button, it's going to automatically transfer to our generator power. Now, this second switch down here is for our timed and immediate transfer. So after, if we transfer from normal to emergency, we're going to want to transfer back. So here, the controller is a factory setting. It's going to take 30 minutes for it to transfer back to normal power after it's already been put into emergency power. And there's a 5-minute timer on the ATS switch itself. So if you want to switch it immediately, you're going to hold this switch here about 10 seconds, and that contactor is going to switch over, and you'll go back from emergency to normal power here. Here's our input screen. So here we have our system pressure, and we have our regular voltage. Like I said, we have about 485, 486 going through our 3 phases here. Coming out of our controllers here are our sensing line. So our sensing line is basically what reads pressure from our fire pump system and our actual controller. And I'll go to that sensing line shortly throughout the installation. So our fire pump itself, this is a 1000 GPM peerless pump. And this pump is driven by a 125 Baldor horsepower motor. So we have two incoming street service. We have our east and west street campus loop. So they actually, they're coming in at an 8-inch street service. They actually tie in and come into the suction side of your fire pump here. So before we even get to the street service goes into the fire pump, first thing it travels to is your fire pump bypass line. This fire pump bypass line is made up of 2 isolation valves, which are butterfly valves, and 1 check valve. This check valve is going to allow water to flow into one direction and prevent it from flowing into the opposite direction. So, say for instance, if we had a power outage in the building and the fire pump wasn't able to operate for whatever the reason is, you're still going to have your street service coming in and still feeding your system at about 63 pounds, which is what we currently have coming into the suction side of the fire pump. So now we're looking at the suction side. We're looking at our suction side isolation valve, which is the OSNY valve. This valve is tampered, so anytime someone opens or closes this valve, you will get an alarm at your fire command station indicating someone is here messing with the valve. So we're gonna flow downwards, and we're looking at our suction side gauge here. So we have about 63 pounds coming into our system. Now if we look at the top of that fire pump there, so that blue valve on the top, that's called our air relief valve. So when this fire pump first operates, we start creating water disturbance and turbulence. So that starts creating air pockets and when the fire pump operates. So to prevent those air pockets from making our pump airbound, that air relief valve is going to discharge any of that air that travels into the system and just dump it from right there. The fire pump runs. So now if we go over to the discharge side, we're looking at the discharge side pressure gauge here. So our discharge and our suction pressure gauges should be reading relatively the same PSI, maybe about 5 or 10 pounds above or below. So here we have our casing relief valve, and it's piped directly at the discharge side of the fire pump. So our casing relief valve is the cooling mechanism for the fire pump. So when this fire pump runs and we're not flowing any water, that from the fire pump operating is going to start causing heat, which in turn is going to start warping your impeller or burning out your fire pump packing. So this valve is going to open up and it's going to dump that hot water, and it's going to keep introducing cool water into your fire pump and keep your fire pump from overheating. And here we just have a bleeder valve just to bleed this line out. So now we're looking at the discharge side of the fire pump. So here we have our discharge side check valve. Anything that goes above this check valve cannot flow in the opposite direction of it. And also anything that's above this check valve is reading your live system pressure. So if we keep flowing up, we're gonna go to the left-hand side of the T. So here's our sensing line. So our sensing line is made up of 2 unions, and these unions are pre-drilled with a 3/32 bit to allow water to actually flow into your controller and the controller to actually read system pressure. So this line here is actually what tells your controller what pressure we're reading into the system. So now if we keep going up here, this is an isolation valve, which is a butterfly valve, and it's actually isolating our fire pump test header. This is where tests could be conducted for the fire pump. If we keep looking up here, we have our discharge side isolation valve, which is a butterfly valve. Closing this valve is going to deadhead your fire pump, and say if you guys did have a fire, you would not be able to pressurize your system to put that fire out just because you have that valve closed you have this valve closed. So the only pressure you'll be getting is your street pressure that's coming in from the street service. Now we're here, we have our jockey pump controller. So our jockey pump controller, you can read your system pressures, and you have your starts and stops, your cut-in and cut-outs, as I'll say. Here's your switches. Well, you have your on and off switch for your controller. You have your auto. This jockey pump will always be in the auto position. You have the off position, and then you have the hand. If you switch this to the hand position, jockey pump is just going to keep pressurizing on its own. When it's in the auto position, it will cut in automatically and it will cut out automatically at 120 on, 130 off. So we have our sensing line that actually goes into our jockey pump that taps into our jockey pump. The same sensing line is also made up of 2 unions. They're also pre-drilled with those 3/32 bit. So our jockey pump suction line has 2 isolation valves on it, and it travels right into the suction side of the jockey pump. So as we can see our jockey pump piping, we have our suction line, which is pumped into the suction side of a fire pump. And we have the discharge side, which is piped into the discharge side of the fire pump. So our jockey pump is our pressure maintenance device. So we will always want our jockey pump to kick on before our fire pump kicks on. So your jockey pump will also be set at 10 pounds before your fire pump kicks on. So the fire pump's designed to kick on at 110 PSI. So your jockey pump will keep you at 120 on and 130 off. So on the jockey pump side, we have our suction side. We have our suction side isolation valve there. So if we keep following, we have our pressure going into the pump. So here we have a casing relief valve for the fire pump here, for the jockey pump here. If we keep following the discharge, now we have our discharge side check valve. If we keep going up, here we see our sensing line to read our jockey pump pressure, and we have our jockey pump isolation valve here. All those valves will always be in the normally open position as well. Fire pump, it's not your full sprinkler system. It's only a component of your sprinkler system. If a sprinkler head was to go off at any certain floor, that means we will lose pressure in the system. If it's a slow leak, say somebody just tripped the valve, the jockey pump is going to slowly bring your system up to pressure. But if not, if we're losing pounds by the second, where the jockey pump can't keep up, your fire pump's going to kick on, pressurize your system, and keep you protected where that sprinkler head is opened at. So for testing, this fire pump requires annual testing that will be set up by your service contractor. So there's 2 ways this fire pump could be tested, or actually 3. One will be at the furthest point of your system. There should be 3 test headers. Second one will be right here through your fire pump test header. And third way would be right here through your fire pump flow meter. So this flow meter here, as you guys can see, I apologize, I missed it, is made up of 2 isolation valves, butterfly valves. And basically we're gonna open our suction side and we're gonna be throttling on our discharge side there. This gauge here is gonna start climbing. Once we're gonna hit our desired GPMs, we're gonna hold it there, we'll bleed it, and that's an acceptable way to test there. That's just another testing form there.
And you go offline when you test?
Yes, sir. We will always go offline when you conduct any. Weekly inspections just consist of just a visual inspections. We'll just take a look at the suction discharge gate, make sure they're reading the same pressure. We'll take a look at our system. So we want our system, currently we got 125. So if we get any, we wanted to keep them within that range.
So what's the duration of your test?
Excuse me?
What's the duration of your annual
An annual test will consist about 20 to 25 minutes.
Oh, that's it.
Yes, sir. A monthly churn test is just a 10-minute churn test, which just consists of dropping pressure, and I'll go through that for you guys. Alrighty. So I'll go through, we'll do some testing. I'll show you guys how to conduct your monthly churn test. So first thing, we'll come over here to the jockey pump. So we'll be looking at our screen here. So our jockey pump is going to kick on at 120 and it's going to kick off at 130. Our jockey pump is always to be set in the auto position. There it goes. And there it goes. So we're good. So now we're going to switch the jockey pump to the off position. So now we're going to go here to our sensing line. And we're going to drop pressure, and then you can just observe the controller as well as we go below 110. And there we go. So it's going to slowly start. Now we're at full pressure. So running, you're going to see bolts are going to completely stay the same. That's your casing relief valve opening. Like I said, it's a cooling. So it's going to constantly dump water to keep the pump from cooling and not overheating. on main relief. Everything's not pretty loud, so everything should stay the same. Amperage is flowing about the same. Now we're gonna stop the pump. Push the stop button one time, and the pump is gonna slowly stop down as well. Fantastic.
Who's responsible for cleaning these drains? Because once I get slow clogged, it's all going to the hallway.
So we're gonna. So it's just because of the grate creating a splash. So we'll have them cut it out so it can just go directly into the drain. That's just the cause of that there. So I want to turn the fire pump on again. So if you guys look here, this is where we should look in normal operation, normal conditions. We have our power available LED on. We have our transfer switch normal LED on, and we have our automatic shutdown disabled LED light on as well. This automatic shutdown, meaning in New York City code, all fire pumps have to be automatic on, manual off. So if this fire pump was to operate, we're gonna have to manually come down here and push that stop button to stop the fire pump. And that is being, we realized there's no fire, and it was just the fire pump is running for whatever the situation was at that point. All these valves are in the normally open position, except for your flow meter line here and your test header valve there. So basically where we test the fire pump, those valves are always going to be in the normally closed position always. All these valves are tampered except your two jockey pumps. Reason being, jockey pumps isolation valves aren't required to be monitored, but everything else in here is monitored. If your fire pump was to kick on, it is alarmed, then you will get a alarm signal at the fire command station. If anyone wants to mess with any of these valves, you will get the alarm at the fire command station as well. Good.